All right. Hi, everyone. First off, welcome to reInvent, and thank you for making it here so bright and early on day one. I've been doing reInvent, I think 6, maybe 7 years, and this is the first time I've had a 8:30 a.m. session on Monday. Cool. So thank you again for being here. Today we'll be talking about app development. Hopefully that's why you're here. We'll be talking about app development, especially how customers like yourself can accelerate app development in your organizations, how you can make sure those apps are actually good, so high performance, good user experience, et cetera, and especially how you can leverage investments you might already have in your company. So APIs, databases, identity systems, DevOps processes, et cetera. And as we do that, we're going to walk through what we've launched in Amplify, AWS Amplify, the last couple of months to really make that easy. Just show of hands, just so we kind of know who we're talking about. How many folks in the audience today have used Amplify before? Okay. The lights are bad, so I can't see that well, but I think I saw about a third. So we'll do a little bit of an intro as well before we dive deep. My name is Mohit Srivastav. I'm a senior manager of product in Amplify, as well as a few other products in our front-end web and mobile space, so AppSync and Device Farm. I'm really excited to spend the hour with you today and hopefully find some time with you all throughout the week as well. I'll be sharing the stage with Arun. And Arun, would you like to introduce yourself as well?
Thanks, Mohit. Welcome, everyone. Super excited to kick off reInvent today, and also for stealing your coffee time in the morning. My name is Arun, and I'm a solutions architect manager with AWS, specifically focused on the developer experience for AWS Amplify. I'm not a veteran like Mohit is for reInvent, but I'd like to think myself as a veteran, being here for 2 times. This is my second reInvent, so super excited to share information with everyone.
All right, thanks, Arun. All right, so with that, let's dive in. We'll start off with what we hear from customers about app development and delivery today, what's working, what's not working. And then we'll use that to segue into Amplify, and we'll talk in particular about what's new to address those challenges. And then we'll spend a good chunk of the talk, I think over half actually, walking through the experience of building a modern app using resources you have in your organization. And we'll walk through both the development phase of the project as well as the post-development phases as well, so how you can get the thing to production. So when whether you are doing, you're an app developer building an individual app, or whether you're looking at unlocking app development in your organization more broadly, very quickly it becomes evident that app development is full stack development. And it's kind of obvious if you think about it. Most features in a modern app require capabilities of the browser or capabilities of the device. And at the same time, they require capabilities on the backend. That could be AWS resources. It could be on-prem resources, typically a mix of both. So app development is full stack development. Now, if you're this front-end team or the app developer, very early on in your app development process, you realize you have to connect to all these existing things in the organization. Identity systems, APIs, data, other APIs. And what typically happens is a lot of bespoke APIs get created specific to meet the needs of a particular application. And that can work for a while, but then what also can happen is that can slow agility, because whenever there's a change that has to happen, front-end team and back-end team have to coordinate. And it can also be just really daunting for the front-end developer because they have to learn a bunch of different protocols, a bunch of ways of doing access control, which can vary from system to system. So what we hear from customers is they implement, or if they don't implement, they at least aspire to implement some kind of backend for front-end layer, a backend for front-end API layer, something like you see in the middle. And the goal with something like this is to really unlock that app development. So the front-end team only has to work with one set of interfaces instead of having to work with all of the different things on the back end. And you'll notice that the backend for front-end layer is not just an API. When we talk to customers, it's an API, but it also sometimes has to include its own stuff as well. So in this particular case, it does include a database, and the database is there to sort of supplement whatever existing systems of record you have in your organization today that have to all come together to build an app. Okay. Yeah, all that said, building that backend for frontend can be quite daunting. And sometimes you might have seen in the industry, backend for frontend is called BFF. But I didn't put that acronym here because it might get confusing with the other meanings of BFF. But building that backend for frontend is daunting. And a few reasons why. First, it has to implement some mechanism of discovery. Like how can that front-end developer figure out all the different data sources that are available to them? What operations are available on that data. Second, there's a bunch of functionality that has to be implemented by that BFF. There I go, I used the acronym, that BFF. For example, real-time data. So if you think about a modern app, generally speaking, there's some kind of newsfeed capability, some kind of notification mechanism. You might want to implement that on top of a database, like a MySQL or Postgres database that wasn't built with that in mind. It doesn't natively have a way of funneling updates all the way back to the client. So these are the kind of things that you have to think about when you build this backend for front-end layer. And then finally, if you're rolling this thing out in an existing organization, of course, you don't want to introduce a completely new DevOps process. You want it to somehow plug into existing DevOps processes and mechanisms. And then on top of all of this, the backend for front-end layer has to both introduce some net new resources, as we saw on the previous slide, and work with existing resources. And when it comes to working with existing resources, there's even more challenges. So, for example, like we just talked about, a lot of legacy systems weren't built to be consumed directly by an app. They may not meet the latency requirements, like they may not have caching and whatnot to meet the latency requirements. They may not be real-time, like we talked about. Or they might not have the granularity of access control needed to make sure that only the right users are accessing the right data. We've already talked about the fragmentation piece. And then, as you implement this kind of intermediate layer, it's important that the end objective actually gets met. Like, does it actually make the app development in the organization faster? And as it gets rolled out, is it compliant with processes you might have? Like, one thing I hear a lot is backend engineers, owners of systems of record are really concerned about giving direct access to app developers. They're concerned they're going to do something to break, to kind of overload the system. So that has to be another consideration as you build a layer like this. Okay, so with that in mind, we've built Amplify, and Amplify is meant to address the particular challenges we've just talked about, but more broadly, everything you might need to build web and mobile applications. What you see on the right side, covers everything around app development. So starting from UI to building that backend, to hosting your application, to scaling it. Today, we're not going to be able to go into depth on all of it. We're going to focus disproportionately on the build and app backend piece. But we'll talk about how that integrates with the UI piece and the hosting piece, just so you can see the full picture. But the big focus is going to be on building that app backend. And if you used Amplify today, admittedly, we've done a better job on building that app backend with a net new set of AWS services. So like if I'm starting from scratch, I don't have anything. That's really what the sweet spot of Amplify has been. As of the last month, including a launch that Arun's going to speak about that's happening right now. It might not have happened just yet, but it's in progress. We've done a lot to make it easier to incorporate existing resources into that app backend. So that's going to be a major focus of our talk today as well, how that app backend can pull together net new things you need, as well as existing stuff you already have in your organization. Okay. And you'll see here a quote of a customer who used Amplify prior to this set of launches, and they were very happy with the ability to really get up and running with an app backend quickly. It pulled together all the different AWS services needed. And the CEO and founder of this company was able to get this ABIT agritech company was able to get their business up and running really fast as a result. Okay, so with that, I'm very excited now to announce what's new. And a lot of what's new is really focused, again, on enabling you to integrate some of the benefits that Amplify provides into your existing organization. So the first thing we've done is, if you've used Amplify in the past, the interface was a command line tool. And we got feedback from customers that that's very good, but sometimes it's at odds with other tooling that folks might already have in the organization. So we've kind of reimagined the experience where now you can author your backend, declare, in very succinct code. And the code is, can be TypeScript, it can be JavaScript, for example. It's very succinct, and it lives in your source control repository, along with all of the other code that you might have. And we'll double-click on this in just a minute and how it relates to things like CDK and CloudFormation that you might also be using as well. The second thing we've done is this kind of abstraction for defining your app backend allows you to pull in existing identity systems and existing data resources. And then finally, because, I'm jumping ahead a little bit, but because all of this stuff is layered on CDK, you can basically pull in anything from AWS, so all the 200 plus services. I'm sure by the end of the week it will be 300 plus. You can pull together all the services that AWS offers into this backend by using CDK. So it's meant to compose really nicely with the rest of AWS. And then once you've done all of this, because everything is in source control, everything is infrastructure as code ultimately under the hood, it's really flexible in terms of how you roll out to production. You can do everything from developer sandboxes, all kinds of continuous integration, trunk-based, Git flow, et cetera. And you can deliver in all the ways you might want to deliver, full stack, multi-account, cross-region. And we'll see some examples of that later. So just double-clicking a little bit more on what's new for app development. So first, this kind of code-first DX. How many folks have used CDK, or at least know what CDK is? Okay, a little bit more hands. Yeah, so CDK is a way of defining your infrastructure, and it's layered on top of CloudFormation, which is the kind of underpinning for how you define infrastructure on AWS. And CDK has this concept of layers. So what we've done in Amplify is we've kind of rewritten a lot of our backend capabilities using CDK L3 constructs, which are really succinct. So a lot of Arundeep's demo is going to be like how you can build out this backend in very few lines of code because it uses these layer three constructs. He's going to do all of his demos using TypeScript. You don't have to use TypeScript. He's going to do TypeScript. And we've also done the work to integrate really tightly with Code Whisperer. So from your IDE, VS Code, or whatnot, you can actually just, you can in comments, for example, say what you want, and it will actually spit out the code for you and help you get up and running even faster. When it comes to integration, you can now bring in existing identity providers, things like Okta, if you're using that in your organization. As of right now, or if not right now, a few minutes from now, you can also bring in existing databases, MySQL and PostgreSQL databases. And what's really neat is once you do that, that's not it. You can augment that. You can add business logic. You can add real-time access. You can add access control, et cetera. And then finally, as I mentioned, because this is all CDK at the end of the day, you can combine it really neatly with other CDK constructs that are produced from the community, provided by AWS to really integrate this app backend with everything that AWS has to offer. And then when it comes to post-development to delivery, because again, everything is code first, you can use any kind of CI/CD approach you like. I'm going to walk you at the end of the talk through one that I recommend, but you don't have to follow that per se. And you can, if you already have CDK or CloudFormation investments, you can combine it with that as well. And just as a brief aside, also when it comes to app delivery, Amplify also offers a web hosting solution called Amplify Hosting. We've launched a number of stuff and a number of things the last couple months or so to address the top feedback we've heard from enterprise customers. In particular, wildcard subdomains can enable multi-tenant kind of architectures, and custom SSL is really important when it comes to integrating hosting into existing organizations. You want to use certificates you already have instead of being forced to use a new one. And this one didn't quite make reInvent, but it's just a matter of weeks before that one launches. All right, so with that, I'm going to hand off to Arundeep, who's going to actually walk through a bunch of these features in action as he builds an app. I'll be coming back on stage periodically to role play with him, but most of the next half an hour is going to be Arundeep. Thank you.
Grab the clicker. All right, thanks, Mohit. So as Mohit was talking about the develop and the delivery phases of an app building lifecycle, we are specifically going to focus on the develop section of the app in the next upcoming slides, right? And I'm going to throw in a fun challenge as well. You all can count in how many times I say under 10 lines of code, okay? All right, so imagine you're a part of a full stack development team at a fictitious healthcare company, patent pending, of course, Medica. And it's a healthcare provider company where you've got like the healthcare providers or doctors, as well as patients. The patients will go ahead and request for an appointment through the app's lifecycle. Now, Mohit and I are going to play the role of a front-end developer. He's going to be focused on the front-end client code. And I'm going to be the back-end for front-end team that he just spoke about, right? Like the BFF pattern. We are responsible for modernizing the application that was built at Medica. Imagine that they had a legacy PHP application built on a LAMP stack. How many of you have still dealing with those frameworks, right? Funny story, we're still living in the 90s. But I thought of including a screenshot of a legacy application, but I didn't want to compromise the slide deck look and feel. You don't want to see that. Anyways, moving along, we received the designs from the UX team, but the app in itself has a dashboard where the patient or the employee can log in, and they can book an appointment, right? It's going to capture the details of the user, and it's going to let you book an appointment based on the available times that a doctor is available, right? And then in the end, if you want to extend the capabilities of your application, imagine adding the capability to have a virtual AI assistant that is going to front-end your appointment booking process. So on the bottom portion of your screen, you have a section called Virtual Assistant. Now, this was something we put together in the last minute over this weekend. So you can actually see that lorem ipsum, the default font that comes in with the designs, are still there. So once we figure out the UX designs from the UX team, so we'll start with the app building process. Now, since we are a part of the front-end team, the same backend can be used by both the web team, Mohit is one of the devs on the front-end client code there, and any mobile developer can also use the same backend, right? So the same logic applies for both web and mobile applications. In order to keep the stock simple and just focus on the simplicity of the architecture, we'll be using web as an example, okay? So none of what I'm saying isn't true for a mobile application as well. It's true. So we'll take a look at the 30,000 feet overview about what are the tech layers involved in the stack, right? Now, as Mohit mentioned, right, like we have L3-based CDK constructs that are available. How many of you have heard about the layers and constructs for CDK? Okay, that's just a few of them, right? So in a nutshell, I'll try to go ahead and explain this as to how I understood it in the start when I was reading for my Solutions Architect Associate exam. CDK provides L1 constructs, which are the underlying CFN resources themselves, right? Like you can use the CFN constructs and define any resources. L2, on the other hand, is encapsulation of the CFN resources and associated services that are required to define this particular service. Like, for example, if you're defining an intent-based API, then you're going to go ahead and define an L2 construct, which has the underlying CFN resources, plus the required IAM roles or required security groups that is needed in order to define them. An L3 construct focuses specifically on a use case or a pattern. Like if you want to define Auth in this particular case, Amplify provides an L3 construct, right? If you want to define data, these are like use cases in your application. They're not like just generic resources that you deploy, okay? So the Auth layer enables users to create new accounts and sign in. The data layer can have two phases. One is the existing healthcare employees and the ability for patients to book appointments with them. And the second phase is also pulling existing patient data and associate billing information to them, right? And the last portion which we'll focus in today's app is extending conversational AI capabilities into your app. Gen AI is the buzz term in the industry right now. So we're going to see how we can incorporate that as well. So let's dive into the 10,000 feet overview of the architecture. Now, this slide can look pretty complicated, but this is one of the patterns that our customers have been using today, right? Thousands of our customers are deploying Amplify using this architecture. But they've always been coming back with like, Arun, what's the easier way of like, deploying this? And today, we make it simpler as we move towards this app of how we can deploy these different tech layers of the stack using CDK, okay? So I'll still go ahead and explain how the backend architecture would look like. So you'd have like end users and employees within Medica who would log into the web or mobile application. The Auth functionality is powered by Amazon Cognito, right? Now, Cognito has the concept of user pools that is going to store the information of the end users directly. And it also has a native integration with an existing OIDC or SAML provider, right? So as Mohit mentioned, you could have an existing integration with Okta if your company uses Okta for single sign-on. But if you have any SAML provider as well, Microsoft Azure, then that integration is possible natively with Amplify as well. And the data layer are front-ended through AWS AppSync. How many of you have heard AppSync? Quite a few of you all, right? So AppSync is a managed serverless GraphQL service. It allows you to scale GraphQL workloads on AWS, right? Now, in order to explain AppSync, right, I'm going to split this down into 3 components. Now, AppSync has GraphQL schema, which defines how your data model looks like, right? Like it's just like the blueprint of your data model. And then you've got the concept of resolvers, which is the business logic of how to fetch the data. And then in the end, you've got the actual databases or data sources in itself where the data actually resides, right? So all of these are the components of AppSync. Now, what we do is we abstract all of that, and I'm going to provide a single AppSync API endpoint to Mohit so that on the client side, all he has to do is interact and query the data directly from the AppSync API endpoint. Right? Now, you could also think that, do I have to deploy the schema independently? Do I have to deploy the resolvers independently? Or do I have to deploy the data sources independently? And that's where the L3 construct comes into picture, right? It makes it easy to deploy it in under 10 lines of code, okay? Now let's split this based on the UX designs for Auth. So in a typical Auth flow, you would have username and password, sign in, and also forgot your password, no-brainer, right? I've intentionally omitted a specific flow. Any guesses as to what could be residing on the Auth flow? Reset password. I think we have the forgot your password, right? Sign up. Yes, thank you, right? So the sign up flow would typically have like a button on your website, right, creating your new account. And the workflow for that would look something like this. You would enter your email address, and you would have fields for your password and confirm password. Now, again, this is the most simplest basic authentication setup that we did over the weekend. But in a typical real-world modern application, you would have multiple other user attributes that you would collect, right? Imagine you signing up for the reInvent website, right? And then for the employee login flow, there would be a button for the employees to be able to log in. And that would be a single sign-on flow enabled through an OIDC provider. And the employees are going to enter their username and password for once. And then based on the token management abilities, they'd be able to continue signing into the application. Okay? So in this particular flow, what happens is the application code grant is exchanged for a JWT token or a JSON web token from the OIDC provider. And that JWT token is managed by Amazon Cognito, which then sends it back to the application. So that's how your OIDC flow is going to function. Okay? So let's see how we can build this with CDK L3 construct for Auth. So all the flows that you saw earlier can be pushed through Amplify Auth L3 CDK construct for end user as well as for employees. And you can easily build registration, sign-in, and authorization rules for the end user. And from an employee standpoint, you can build the OIDC and SAML flows. And you can also use the ability of Cognito user groups to create a group called admin as well, right? Like in a healthcare company, you've got the healthcare employees or the providers, but you also have admins who can manage the billing information and the patient information. All right. So in order to accomplish that, we'll define the backend resources using the L3 construct. In this particular code example, I've used TypeScript in going ahead and importing the Amplify Auth construct. And I'm going to instantiate this Amplify Auth construct, name the user pool as Medica Auth. All that I have to do is set the email option to be true. So I'm providing an object called login with, and email is true. And that is going to set up the user pool for the end users, right? And in order to set up the backend for the OIDC flow, I just have to pass in the parameters for the client ID, client secret, and issuer URL. And that enables both the flows for the backend, right? Again, all of this in under 10 lines of code in the CDK stack file. Once I hit CDK deploy, it's going to deploy the necessary resources for Cognito, and then that's it. Right? I'm going to invite Mohit up here to talk about how easy it has been for him to integrate that on the client side.
Thanks, Arun. Okay, thanks, Arun. So before I do that, just a quick aside. Another aspect of Amplify besides these L3 constructs for configuring the backend is a rich set of client libraries. And the client libraries reduce the amount of code that me as a front-end developer have to write to implement auth flows, which you'll see here, as well as data flows like that real-time newsfeed scenario we talked about earlier, which you might want for real-time updates to data, or even in generative AI kind of flows if you want a chat experience on top of generative AI. So with that said, when it came to doing the employee login first, I kind of had two choices, and I'll kind of explain the pros and cons of the two choices. The first choice is the one that Arundeep spoke about, is arguably the simpler approach. So I just configure, as you see here, some redirect URLs. And the Cognito service, the Cognito user pool service, handles all of the token management. And let's say I'm using Okta, it handles all of the handshake with Okta. So me as a client developer, I'm aside from just configuring the redirects, I'm basically hands-off when it comes to the interaction with Okta. All of that is handled between Okta and the service. So this has the nice benefit of being really easy. Token management is handled for me. End user experience is they don't even know that Cognito is necessarily there under the hood. It's really, really smooth. Alternatively, I could take a different approach. Let's say I've been using Okta again as my identity provider, and I'm using the Okta SDK. I'm using the Okta SDK because I want to take advantage of something on the client using the JWT token I get back from Okta. I can certainly do that as well, and that's what this flow is doing. Again, in 10-ish, I don't know if it's exactly 10, but 10-ish lines of code. I can use Okta SDK as I otherwise would, and all I have to do is kind of bootstrap Amplify, if you will, by passing the token that I get from Okta. And then I can use that to now have my app access AWS resources on behalf of that Okta user, and I can continue using the Okta SDK. Both approaches completely valid. It just depends on your use case and the needs of your app developer. For the patient login, right, the patient login in theory is more complicated because I don't have something like Okta to fall back on. I need to actually implement sign up and sign in flows and manage that myself in my application. So that in theory could be thousands of lines of code. Like if you start thinking about all the user interface to do an auth flow properly, the crazy state machine you might have to deal with the different multi-factor auth flows, so the ones that you first do when you sign up, and then subsequently when you sign in, that can be thousands of lines of code. And we've really tried to abstract that on the client in Amplify so you can build the entire authentication flow in minutes. And it is layered. I've showed you what I'm showing you here is the highest layer of the stack. It's called the Amplify Authenticator. And that actually gives you a full out-of-box built-in UI. So you can see here in just a few lines of code, I've configured my client login flow, and it automatically works with whatever settings are configured on that CDK construct. And it's completely themable and stylable, so you can use it to match, in this case, Medica's design guidelines. That said, if you want more control, you can always go one level under the hood, which I haven't shown here, and implement your own UI as well. All right, back to you, Arun.
So let's take a look at the data layer of the app now. At a minimum, we are going to have an appointment booking form where users can come in and book their appointments with name, description, and as well as the provider information, an optional date picker component to choose a date, right? And the information of the doctors can be stored in a new Dynamo database that we are going to create. And we are also going to associate bills of the patient. And this existing billing data can reside on a MySQL database, right? So let's simplify the architecture. Right? What we spoke about was appointment and healthcare data residing on Dynamo, and the patient and billing data residing in an existing MySQL database. And both of this is going to be deployed and integrated with through AWS AppSync GraphQL L3 construct. Now, this is going to be released today. We just approved the PRs in the morning, so You can do an impress your friend kind of a thing at the hallway that you were the first ones to receive this information. Okay. So the first step for that is to define your appointment schema and API, right? Now, with GraphQL, you have to define your schema. And the schema for the service provider has a unique ID, and it's got the name, specialty, whether they're a cardiologist, whether they're a dentist, whatnot. And then it's got a relationship with the appointment, right? Now, typically, one service provider can have multiple appointments. And in order to define that relationship, we use the has many directive, as you can see on the screen. And on the appointment side, right, it's got, again, a unique ID field. It's got a description field, a time field, and a relationship back to the service provider. Now, the same appointment can also have relationship with like patient ID and bills as well, right? Now, we have not spoken about the patient ID and bills in this particular schema just yet because we have minimized this to show the relationships, but those are existing on a MySQL database in your organization, right? So we're going to show in the next step as to how you can integrate that, okay? All right, and on the main CDK stack file, you're going to go ahead and use this construct. Again, starting 11 a.m., you'll be able to use this live in action. And you can instantiate the construct using the name of the API, right? And then you can go ahead and specify different authorization modes. For simplicity, we have used the API key, but the construct supports all authorization modes that is supported by AWS AppSync. You can do IAM, you can do cognito user pools, or you can even have your own custom authorization using Lambda. Okay? So this is, again, the deployment of the appointment schema API in under 10 lines. All right? Now, because the patient and billing schema already existed on an existing MySQL database, you can use any SQL Explorer, right? How many of you used MySQL in the past? What tools would you use to connect to MySQL? Workbench. Cool. Workbench is the screenshot there. That's the same thing that I used. You can output the schema into a CSV file, and Amplify provides an easy, succinct command to be able to take in the CSV file and generate a schema.sql.graphql file, right? Because you have a relational database, and you'd want the schema to go ahead and interpret that as GraphQL schema, right? So the output of that is going to look something like this. Now, this has automatically been generated by the command. I did not have to write the schema myself, right? Now, the type billing refers to the billing table in your database. And you have different authorization rules. Here, I'm using cognito user groups to say that only the admins can have CRUD operations because you don't want the patient themselves to be able to add or delete bills on their behalf, right? You want the admin to be able to control that. But as the owner of the record, like if I'm a patient or if I have a bill associated to me, I should be able to see the record, right? So allow the owner of billing data to be able to read, and only the admins can perform CRUD operations. And the same thing for patient as well. Now, you've seen that the patient has fields for first name, last name, and address. And again, in a typical real-world healthcare company, there will be much more attributes that define the patient, much more attributes that define the appointment as well. Okay? And we are going to use the same construct that we spoke about earlier. And though the construct was released back in October, today we are adding the SQL support, so this should work. And you can take the SQL.GraphQL file, and you can specify the DB connection parameters, so where your database resides. So for example, if you have your MySQL database in RDS behind a VPC as well, you can specify the connection parameters, and you can use the authorization modes of user pool, right? Okay, so now that we have defined both the APIs, initially what I said was Mohit will be able to query the client or query from the client using a single API, right? And because we have two different GraphQL APIs, that defeats the purpose. So you have appointment and healthcare employee data being managed by team A, and the patient and billing data managed by team B. You have GraphQL APIs for both of them. And AppSync now offers merged APIs, right? With that enable federated cross-team API development. This means that APIs owned and managed by independent teams can be merged and combined into a single API. And the schema of the individual source APIs is also going to be merged. So are the types and the resolvers in the backend as well, right? Now, what this enables the front-end devs to be able to do is they can query that data from a single endpoint. And on the backend, both team A and team B can release changes independently without blocking on changes on the merged API, right? Right? And here's a customer quote from ADP. ADP is automatic data processing that provides human capital management as well as enterprise payroll services. They've used AppSync to bring data from various backends and sources into a single endpoint. Right? So now that we have initialized auth and data in our application, let's focus on extending the capabilities of app. Right? Like, so now, how many of us are comfortable with using chat-based assistants to book an application? Just a few? All right, cool. So imagine you don't want to pick up your phone each time or go into the website because you may be driving or you may be in different setups. So if your appointment booking app want a mechanism to identify the service provider automatically based on their preferences and needs and go ahead and provide a recommendation, how cool would that be, right? And these are the things that Amplify allows you to provision using CDK, where you can connect to any AWS service, right, in order to get the functionality. So let's again take a look at the UX designs. Every industry is actually experiencing this monumental shift in technology. They're trying to make it more simpler to use AI, NLP, and now more commonly generative AI. Here, imagine that there is a chatbot called Medica AI chatbot that automatically figures out the preferences of the patients and makes a recommendation of an appointment, right? And the user, on the other hand, all that they have to do is to accept or deny the recommendation, okay? So this enables personalization capabilities, right? So the service that can be leveraged in order to do that is Amazon Bedrock. How many of you have heard of Bedrock? Right? So Amazon Bedrock was launched earlier this year. It provides the easiest way to build generative AI applications on AWS. It front-ends a lot of the large language models, or which we call as foundational models, offered by Meta, Anthropic, Stability AI, and Amazon itself. Right? So we're going to grab the user preferences from the employee. We are also going to associate that with service providers' metadata, and then we'll provide the recommendations back to the users. Right? So a quick look at the architecture again. The integration between Bedrock can again be abstracted and set up behind AppSync. So you don't have to worry about setting each one of them up individually. AppSync can use a HTTP-based resolver because Bedrock can be defined using a HTTP endpoint. You can just call or invoke the HTTP endpoint and the model behind them, and you should be able to communicate with Bedrock from the client side. Right? And here's the code, right? This is the only code that is not under 10 lines, at least. But you can add Amazon Bedrock as an HTTP source and provide the permissions to invoke the underlying model. In this example, we have used Anthropic Claude model. And then we're going to add a resolver, and we're going to use a file called generaterecommendations.js. And in that file, we'll say that the prompt for the model is going to look something like this, right? Imagine that you are a healthcare AI assistant responsible for booking applications. And you need to respond back to the user with the available time slots, right? And that could be the prompt that is in the recommendations.js file. And that will be taken as a code asset, and it will be attached to Bedrock as an AppSync query. Now, there is a QR code as well on the slide. One of our developer advocates, Michael, created a spicy chicken taco recipe app using the same pattern. Right? It's not Tuesday, I know that. We can all wait for Taco Tuesday tomorrow, but you can scan the QR code to check out the GitHub repo for the code as well. And that's fully functional. Now, there's a second pattern to have AppSync as a connector to generative AI. We talked about the HTTP-based resolvers, but you could also have a Lambda resolver that connects to Bedrock. And there is a blog post that we wrote recently in order to show you how you can use this particular pattern. So if you scan the QR code, it'll link you directly to the blog post. Right? Here's a demo just to prove that whatever I've been talking about Medica is not untrue. There is a demo here. You can scan the QR code. It's a live website. There is a username and password that's defined on the website, which expires after 24 hours just to protect the website from multiple requests. So you can try it out over coffee. But Dan, one of my colleagues, and we built this over the weekend. And funny story, right? I have a demo coming up for it. Initially, we were told no demo, but YOLO, right? We just went and created this. It is actually funny that we took a lot of time to edit this video than the time it took to spin up the code and use Amplify L3CDK construct. Right? I'll let it up to the user's imagination to figure out what's true in that.
Hello. Today I'll be demonstrating an application that can be created with CDK, AWS Amplify, and using AppSync's merged API feature while maintaining relationships across the API sources. The experience that I'll be showing today is one of two experiences. The first being users who can go in, request appointments, and view a history of their appointments, and providers who can go in and manage and view appointments that have been created by other users. So here's a sample app that we currently have right now. And with the patient login, I can go to that page. And as a patient, I can enter my credentials. And click login. When I'm logged in, it will show me the list of appointments that I currently have historically and in the future. As you can see, I have 2 appointments coming up, one with Dr. Pepper and one with Dr. Strange coming up next year, while also showing the billing amount for each of these appointments. The key thing to note here is there are 4 separate data sources that are all being used by the merged API feature to put this data together. We have a provider's data source, we have a user's data source, we have a billing data source, and we have the appointment data source. So the merged API feature maintains relationships across all of these different 4 data sources, exposing them through one endpoint. In addition to viewing my appointments, I can also come in and set up an appointment. Here, as you can see, I can select the list of providers that are being exposed by the data source. So I'll say I want to see Dr. Strange, and let me set this for March 13th of next year. Once I do that, I'll hit book, and once that's successful, it will add it to the list of appointments that I currently have. You can see this is the one from March that I just created. It's also, after some backend magic, it's also kind of given me my billing amount. Next, I'll be showing the provider view. So here, using Okta, for example, as your OIDC provider, I can click on the provider login link. And with the use of AWS Amplify, it already knows that I have an Okta session on this browser, so it automatically signs me in. And beyond seeing the previous users' appointments, I can see an extra one here. So in total, we currently only have 4 appointments. Dr. Strange seems pretty popular. And as a provider or as an admin, I can view all of the different appointments.
All right. So it's as easy as that. Seem pretty popular, but essentially we have built this app out, and you can use the QR code to actually test the website out live as well. I'm going to hand off to Mohit to talk about the deploy portion.
All right, thank you, Arun. All right, so coming back now to the underlying tenet behind everything we've been showing today is this kind of code-first approach. And the benefits of that extend to beyond development to delivery as well. And here's a couple of patterns that are possible because of the code-first approach. The first one is it's possible for each developer to have their own developer sandbox, and we'll see exactly how that works with a short demo actually in a minute. But basically, each developer can take the code that defines this backend for front-end layer. They can work on it. They can round trip it to the cloud, interact with it even before you start CI/CD. Once you enter CI, again, code first allows you to use mix and match, your preferred CI. I think the two common ones are Git flow or trunk-based. Folks would argue they're actually not that different if you kind of dive into it. But the point is, code first allows you for flexibility on CI. And then finally, especially for more sophisticated deployments, you can do truly full-stack deployments, front-end and back-end together. And you can do multi-stage and cross-region as well. And we'll see a pattern around that. Okay, so let's start with what exactly do we mean by per developer sandboxes. So here you see an example where I have 3 folks on my team. My eyes are not good enough to see who I had picked, but these are actually people on my team. 3 folks on my team. And I have a setup here where the developers working on the front end are also the developers working on this backend for front end layer. And the key thing here is whenever they hit save in their IDE, a couple things happen, right? Their local browser will refresh. And in addition to their local browser refreshing, if they made any changes to the backend, the CDKL3 construct, that will get automatically deployed in the backend. It will kind of be bypassing CloudFormation and just automatically get deployed really quickly in a matter of 10 seconds or less. And what this allows is for all of these folks to work on the backend for front-end layer together, independently prior to their code changes entering CI/CD at all in the first place. So to see this in action, here's a short video. Let me hit play. Okay, so I've taken that schema that Arundeep created, and I don't like name. Instead of name, I want first name and last name. So I'm going to go ahead and make the change. So you'll see here, I'm going from name to first name and last name. And I hit save. Right when I hit save, we're using a capability of CDK called CDK Hot Swap, which you invoke with CDK Watch. And in about 10-ish seconds, you'll see that these changes actually round trip to the cloud. So in this case, they're going to round trip to AppSync. They're going to round trip to DynamoDB. And now if I flip to AppSync and look at the Query Explorer in AppSync, unpack an API that uses that schema, indeed, I can see that instead of name, I now have first name and last name available. So what this allows developers to do is kind of get the best of both worlds. In the past, we've had things like simulators and mocks, which can be fast, but developers say that's not really high fidelity. It's nice, but it's not high fidelity. So this gives developers a truly high fidelity cloud environment, but with nearly the speed of local development. In 10 seconds, you saw we were able to round trip and see the impact. Once you get past sandboxes, you can implement the CI of your choice. The kind of traditional CI where everybody has access to the main branch is certainly possible, and the most recent check into the main branch represents the code that's deployed to production. You can also, for sure, implement branches like you would have in Git flow. So if you take one of those developers on the previous slide, now they're happy with their first name, last name change. They can check into source control into their feature branch. In this case, I've called it developer A. They can submit a PR. When they submit that PR to the main branch, that first name, last name change is now applied to the main branch and hence can get rolled out to production. Right? Alternatively, you could have a deployment that aligns with the developer A branch as well, like a test deployment. Okay, now going past CI to CD, a pattern we often see with customers is full stack CI/CD. So what you have on this slide, the first part is exactly what I showed. It's basically a workflow where the backend gets deployed. But to make sure that the backend and front end stay in sync, after the backend is deployed, on the lower half of the slide, you'll see that the front end build gets kicked off. So the front end build gets kicked off, a front end test phase happens, and only if the front end test succeeds does the entire thing then get deployed. If there's any failure, you can have a rollback. And this is a really nice pattern where, for scenarios where you might have a front end and a back end for front end team that are the same team, right? This can really streamline the continuous deployment of both aspects together while ensuring that there's no drift between the two. And getting a little bit more sophisticated from that, the code-first approach allows you to grow up to something like this. So what you see on the left-hand side now is not just a single stage, but multiple stages. And what you have here with these multi-stages is an initial build, but then after you have that initial build, a rollout to different phases. So here, I think I've chosen 3 phases, but they're all the phases except the last phase are basically pre-prod integration sort of phases. And then the last phase is the last phase or stage is prod. So basically by using that same app code, you can run it over and over again in different stages to a different effect. You can either support your pre-prod or your prod deployment. On the right-hand side, you see that the flexibility this allows is multifold. So first, you can have different stages output to different accounts, because you may not want your front-end developer or your BFF developer to have access to prod. So here, you can you can implement different accounts, again, using that same exact sort of app code, CDK stack Arun Deep built, just by changing configuration parameters, you can roll out to different accounts. And likewise, by changing configuration parameters, you can roll out to multiple regions as well. So if you see the last phase here, the last phase is actually doing multiple deployments. It's doing deployments to different regions to enable kind of a multi-region architecture. Now, being fully transparent, this gets you like 80% there, 90% there. Obviously, a multi-region architecture is more than just deploying the same stack in a lot of different regions. There is some work you have to do to make sure the regions can work together as needed. So for example, you might want DynamoDB global tables. So the underlying data is replicated across regions. So this gets you 80 or 90% there. For the last 20%, we have a QR code here. We've written a blog post which shows how you can take the stuff we've talked about today, make the incremental changes like turning on DynamoDB global tables to end up with a truly multi-region architecture. All right, so with that, we're coming to an end. Just want to recap what we've talked about today. We talked about Amplify, and in particular, some of the new stuff we've done in Amplify over the last few months to really make it easy to fit Amplify in your organizations. We've really leaned in on this code-first approach available via CDK L3 constructs. We've made it easy as of 11 a.m., apparently, to integrate with existing identity and databases. Made it easy to extend and use any AWS service via CDK. And then by kind of doubling down on code first, which under the hood is actually infrastructure as a code, not infrastructure as code, you have complete flexibility when it comes to CI/CD, as well as creating developer sandboxes prior to your CI/CD. So with that, I want to extend a big thank you to the audience. Again, I know it's not easy to come out 8:30 in the morning, Monday, first day of reInvent, so big thank you for being here, hanging around. Our contact information is here. We're active on all of these channels, so absolutely feel free to reach out if you have any questions. We have a front-end web and mobile blog as well, which has all of our latest announcements. You can go there for tips on how to get started. But with that, I want to extend a big thank you.